Hello, math humans. We're going to do 3.3 today. We're going to be talking about the first derivative test. Our objectives are that we're going to determine the intervals on which a function is increasing and decreasing, and we're going to apply the first derivative test to determine extrema. All right, so let's go back to pre-calc and talk about a function. So let's say here's my cool function. Okay, so we'll call this guy f. And I'm going to label that point A, and I'm going to label that point B. If you'll remember, we could talk about where the function was increasing and decreasing. So we would say here's the increasing slope. This slope is increasing. This slope is decreasing. So from pre-calc, we would have said f of x is increasing. And I would have said from a negative infinity to a, and remember it's always an open bracket because we don't know the point at exactly where things change. And then it's increasing again from b to positive infinity. And then f of x is decreasing, and it's going to decrease from a to b. And remember, we're looking at the slope of the function. Well, when we talk about calculus, we're not going to do it just by looking at the graph. Of course, we're going to do it with the derivative. So here's my next graph, and let's say it looks something like this. Here's my function, kind of cool looking function. Get all my little arrows on there. And I'm going to call this point E, and I'm going to call this point F. Okay? Alrighty. So in calculus, when we talk about where a function is increasing and decreasing, for calculus, I'm interested in where is f prime of x positive and where is f prime of x negative. So it's still the same basic concept, but the notation is different, and the way that we find our information is going to be different. So notice on this one, this portion of the graph is decreasing, this portion of the function is increasing, and this portion of the graph is constant because it has no change in the y values. So I would say f prime of x is greater than 0, and it would be from f to positive infinity, and then this would be where it's increasing. And then I could say f prime of x is less than 0 from a negative infinity to e, and that would be where it's decreasing. And then f prime of x is equal to 0 if it's not increasing. If it's constant, then it has a horizontal tangent, and that's going to happen from E to F, and this would be where the graph is constant. All right, so let's start with an example. So for example 1, I want to determine the intervals where f of x, and we're going to get it is x cubed minus 3/2 x squared, is either increasing or decreasing. So there are two basic approaches. One is a pre-calc approach and one is a calculus approach. So I think I'm just going to stick with the calculus approach, and they're not that different. So for calculus, the first thing that I would do is take my derivative, and I'm going to get 3x squared minus, here's the 3/2, and then 2 and x. The 2's cancel, so this is 3x squared minus 3x. Remember, I want to find those horizontal tangents because functions change. I think you can still see this one. Functions change, increasing and decreasing, where I have a horizontal tangent. Alrighty? So what I'm going to do is I'm going to set my derivative equal to 0, and I'm going to find my critical values. And that's going to be where the function has a horizontal tangent. So if I do that, I'm going to get 3x, I can factor that out, and I'm going to get x minus 1 is equal to 0, and I'm going to get x is 0 and x is 1. So now it's going to be the time when we go back and use a sine chart that I taught you in pre-calc. So basically, I'm going to put those two critical values on my graph, and I'm going to label that this is the derivative so you don't get confused, okay? And I'm going to evaluate the derivative, not the function, because I'm looking at positive and negative slopes. I'm going to evaluate these. So I'm going to evaluate this at a negative 10. I'm going to evaluate this at a half, and then I'm going to evaluate it at a positive 10. And those are just numbers that I've chosen in each of those intervals. So if I evaluate the function at a negative 10, remember all I'm interested in are the signs. 3 times a negative 10 is negative. A negative 10 and a negative 1 is more negative. So then this is positive. So the slope is positive, okay, or the function is increasing. If I evaluate f of a half, the first one is positive right here. A half times this is negative. A positive and a negative, negative. So the function is decreasing, or the derivative is negative. And then if I do the next one, f, and I should put my little primes right there, f prime of 10. 3 times 10 is positive. 10 minus 1 is still positive. Net effect is positive. I have horizontal tangents can't spell today, at x is equal to 0 and 1. This one, my graph would be an extrema, right? So I'd have a horizontal tangent there, and decreasing to increasing, I would have a horizontal tangent here. So it says determine the intervals where it's increasing. I'll write it up here so I can get it all on one page. F of x is increasing from negative infinity to 0, and then from 1 to positive infinity, and then I can say f of x is decreasing, and then that's going to be from 0 to 1. And remember, the endpoints aren't included. Let me put a box around that so you can see it. That is my solution to that particular problem. All right, so let's move on and talk about the first derivative test, okay? So the first derivative test allows us to find those points of extrema and talk about what's happening to the graph. We will build on this in this particular chapter. So f has to be continuous and differentiable, and it's going to show intervals of increasing and decreasing and extrema. So that would be what the first derivative test is used for, okay? In the last problem, in the last example, I managed my information with a Sine Chart. That is my particular preferred method, but a lot of people like doing a table. So let me show you what that would look like. So this is the last example, minus 3 halves x squared, and we said our derivative was 3x squared minus 3x, and then we factored our derivative and got x minus 1, and then we got x is equal to 0 and x is equal to 1. So some people will manage this information in a table. The first column is going to be the interval, okay? That's going to be across the top. And then I'm going to have a test value. And it's the same basic thing, it's just another way of managing information of f prime of x, okay? So if I had from 0 to 1, I'm going to do a negative infinity to 0. That's my first interval. And then I had 0 to 1. That's my second interval. Oop, I'm running out of room. And then I had 1 to infinity, okay? That's my third interval. And then I would put in the test values. That was our negative 10, the half, and the 10. And we got that this was in positive, we got this was negative, and we got this as positive. I don't care how you manage your information. I do it on a Sine Chart. Some people like to do it in a table. So let's talk about, that means that our function is going to look something like that. So I'm going to have a horizontal tangent right here. And I'm going to have a horizontal tangent right here at x is equal to 1. So you can see the same information. I just like to use a sine chart. That's my comfort zone, but either method is appropriate. All right, example number 2. I want to find the relative extrema for f of x is equal to 1/2 x minus the sine of x, and I want to go from 0 to 2 pi, okay? And we're going to use the first derivative test. So here's my function. F of x is 1/2 x minus the sine of x. My derivative, f prime of x, is going to be equal to 1/2. The derivative of sine is cosine, so the sine stays the same, and I'm going to set that equal to 0. So I'm going to get a negative cosine of x is equal to a negative 1/2, and then I get the cosine of x is equal to 1/2. And then let's go back and remember our trig. Cosine is positive in these two quadrants. This is a 1, 2, so this is radical 3. So x is going to equal pi over 3 and 5 pi over 3. So now I'm going to do my sine chart. Okay, so I'm going to put those values. I'm going to put the 0 right here. I'm going to put pi over 3 because it restricted where we're going to look for extrema, so that's why I have an end point this time. And then I'm going to have 5 pi over 3, and then I'm going to have 2 pi. So I'm going to pick values in each of these intervals. So I'm going to pick pi over 4, I'm going to pick pi, and then I'm going to pick 7 pi over 4. And I'm picking values that make my life easy, okay? So when I do my evaluation, so I'm going to evaluate the derivative, f prime of pi over 4. So my derivative is 1/2, so this is going to be 1/2 minus 1 over radical 2. So this is going to end up being negative. Negative. So I'm going to put a negative, and I'm going to draw it on my graph because I think the visual is helpful. If I do f prime of pi over 3, and if this math is difficult, you can absolutely show your work, which is what I would normally do. And actually, I'm testing pi. I'm not testing the endpoint. I'm testing pi. And I'm going to get 1/2 minus. The cosine of pi is negative. Negative and a negative is a positive, so that means this is positive. And then if I test the derivative at 7 pi over 4, okay, I'm going to get a negative, and so then my graph is going to do this, okay? Alrighty. So what now that I have, this is a minimum, so I'm decreasing to increasing. Here's a horizontal extrema. And then I have increasing to decreasing. Here is a horizontal extrema. And it says find the relative extrema. So I'm going to report my answers. I have a relative minimum, and I don't know what the rest of the function is doing, so it's going to be relative at x is equal to pi over 3, and I have a relative maximum at x is equal to 5 pi over 3. All right, a couple of things to point out. You always want to answer the question that's asked. This just said find the relative extrema. It didn't say find the point, so I don't have to report the y values. I could also have said I have a relative min at pi over 3 and f of pi over 3. I highly recommend that you do not evaluate the function at that point, because if you make a mistake, then you get it wrong. This just shows that you know that you're going to evaluate the function, not the derivative, to find the corresponding y value. And then I would have a relative maximum at the same thing, 5 pi over 3 and f of 5 pi over 3. The goal is to minimize the number of mistakes that I'm making, and so I want to make sure that I report well without creating error for myself. Alrighty, that is it for today. I will see you soon.